system occur on my side. Okay.
Okay, I record it now. So I have a 33 bus system. Okay.
Okay.
And
Okay.
for example, at a specific bus, for example, at this bus, I have an electric vehicle charging station. Okay,
Okay.
charging station.
Station.
Okay, it is fixed at this bus. Fixed
Okay.
at, for example, bus 18. And then I have for this charging station, I have like 3 options. Okay, or 3 modes. Okay.
Okay.
Firstly, or 3 scenarios. The first scenario, I will consider that this charging station has only fast charging.
That
So
will be DC charging station.
yes, it is fast charging.
Okay.
Yeah, it's just fast charging. Okay, so it takes, for example, high power, high power and less time.
And
Takes less time, for example. You know, fast charging takes like a bunch of electricity, high number of electricity. Okay.
okay.
Second scenario, this is scenario 1. Scenario 2, the charging station will have fast charging, like the first one, and has also vehicle to grid capability. So, for example, if an electric vehicle is connected to this charging station, it can the car can discharge into the station, cancel
Oh,
the, the charge, for example. Scenario number 3, which is the hardest, the station will have fast charging, vehicle to grid, and also we will have PV panels. Like
okay.
you can consider it as like a DG, right? It's like a power source.
Exactly.
Yeah.
Yes.
So these are the 3 scenarios. Okay. Now for each scenario, okay, for each scenario, the main objective, the objective function, you can say, I have 2 objective functions. Okay.
Okay.
The first one is the customer satisfaction.
Okay.
Customer satisfaction, we can research about it, but what my professor told me, he told, for example, the queuing. You know, a car can come, for example, okay. I need to maintain the satisfaction that the customer is happy, for example, okay.
Okay.
So, for example, he wants to charge fast, for example. He doesn't want to stay in line. You know, the queuing. Okay.
Okay.
Yeah. Second one, so this is the satisfaction. Satisfaction has queuing. Okay. We can research about it. Second one is the maximizing the profit for the aggregator. So the aggregator is the one who is operating the station. So,
Yeah.
for example,
EV station. EV station.
yes, exactly. So, for example, uh, okay. So these are the 2 customer
Constraints.
service. Yeah,
Oh, sorry.
customer
Customer
satisfaction.
service. Okay.
That plus we can say it as aggregator satisfaction also. Okay. So queuing, okay, and also the maximum profit for the aggregator. So the aggregator should like sell price and some stuff like this, such that he can uh, have the maximum money. Okay, the maximum money.
Okay.
Okay, so this is the objective functions. Okay,
Okay.
customer satisfaction and aggregator satisfaction. The third thing is the constraints. Okay,
Okay.
so this station is connected to a 33 bus system, right?
Exactly.
Yeah, so I need to maintain at every possibility, or at every queuing, at every whatever, the constraint will be the
For all
voltage
th
at,
for all 3 scenarios, and for customer satisfaction parameters
yeah, at
and all.
every, yeah, exactly, at every point I need the voltage of the buses need to be between this.
Okay.
0.95 per unit and 1.05. Uh, Also, the current in the lines, because the station will have many cars. For example, I didn't choose a number, but we can choose like a number of cars. I don't know.
Okay.
We can do it variable also. We can make it variable, and for example, I can hear cars in a station can be maybe can be variable. Okay, and for example, maximum limit maybe uh, 20 car, for example. We can choose it. It's not a problem. Okay, so this is the first point. The second point also, the constraint, second constraint, the current in the lines. Okay, so here, since this is taking huge power, for example, 10% penetration, 30%, 50%, okay,
Okay.
a specific number, more current will go like this, right? So I need the current to be within like less than the rated current, okay, less than the maximum capability of the line current. Third one is the power losses should be minimum. Like the power losses should be like decreased, or like we don't want a high power losses. This should
Okay.
be okay. Okay, so here I wrote like 2 points, like to consider. For example, how many lanes in the car? For example, here I said 20 car, like 3 lanes, for example, like gas station, for example, petrol station.
Okay.
But it's fine. I can limit it to 20 car. It's fine. Also, how much to consider in the discharging? Since here we have 3 scenarios, here will be no discharging. Okay. But here, when we have vehicle to grid, the car can discharge, right? So I need like to know the charge in the car, and I need to know how much I profit if I discharge a car and something like this. So it like has a cost. It has like we need to know the prices of the charging, the prices of discharging. Okay, you get what I mean?
Yes, I get. Okay, I have one question here.
Yeah.
For 3-point operations, first of all, we have fast charging. Okay, and for
Yeah.
second scenario, S2,
Yeah.
you means we have to charge our grid from our vehicle. From our vehicle, we have to charge our grid, right?
I no here it means like I have like the charging stations has like 2 features. Okay,
Okay.
the charging station itself has 2 features. There are like some vehicle to grid machines, for example, vehicle to grid stations or ports, and here we have like fast charging. So
We
the charging
okay.
station, yeah, supported the 2 features.
Okay. So it means we have here we have two options. We can charge our vehicle, or we can discharge our vehicle for
Y-
V2G.
Yes, exactly. I can charge a vehicle fast or slow. I can discharge to get like highest profit for me as an aggregator, and the queuing should be like less,
Okay, just
like cars. Yeah.
tell me more about queuing.
Okay, so queuing is like when you go to like to refuel your car. Some people, for example, want to go to like their work. So they, for example, can pay you more, for example, and you charge them fast, for example, or something like this. But they will need to pay more than average people. So, for example, if I want to charge in 15 minutes, okay, I will give him like very high charging rate. Like the power consumed, for example, for this car should be very high. So such that the car can take less time, but he will need to pay more money. More money.
Okay.
The, this is the queuing.
Okay, so he will pay more price and he will give the priority or seniority. He can charge first. So,
Yes, exactly.
another thing you mentioned that we have to mention price here for maximum profit of for aggregator. So, is there any formulation or price calculation available within your
Um,
document?
till now, I can't find one, but I think we can like try to get like prices. For example, in any country, for example, in Europe, you can see like for example the 24 hours. How much is the price? I think it is like there is like some books in the USA available content. They have like the prices uh, of the charging of the prices of the electricity for 24 hours. For example, we can have like some data like this. I think it will be something like normal distribution. I'm not
Okay,
sure really. Yeah.
just a moment. Let me think some parameter.
Yeah.
Okay, so
Mm.
just zoom out the picture. Okay,
Yeah.
scroll up, scroll down, scroll
Down.
down, down, down. Okay, so sorry, up, scroll up.
Up.
Just show me IEEE 33 bus network.
This
So
one.
first of all, this one, yes. So first of all, you mentioned the placement for EV that is that you fixed here 18. So you want to fix it at 18, or you want to change it to
We can
any other
fix it at
location?
anyone. We can fix it at anyone. I think it's fine to fix it anywhere. Like it's not the main point. Yeah, we can fix it
Okay,
location. So
okay,
I
we will.
don't have to do the location stuff.
Okay, we will fix it here at 18 number, and then we have fast charging. Will mode of operations will be done. Uh, these
Yeah.
will be done. No need to worry. So just scroll down here.
I think this one will be very hard with this one. I'm not really sure, but I think it will
No, no,
be kind of hard.
it will be not. It will not be difficult. The scenario here, difficult scenario here is customer satisfaction, because in
Yes, exactly.
mode of in third mode of operation where we have FC VTG plus PV. In PV, for PV you have to provide your PV details. I will generate size of PV according to the data you will provide me. I will calculate PV size and then I will add it to this mode of operation. This will be done. No need to worry about, and no need
Maybe
to
we
worry
can
about.
fix it. Maybe you can fix a PV value. I don't know.
Okay,
I'm
in the
really
start.
like, yeah, I'm really just like new in optimization. That's why I talked to you. I don't know how to do optimization. That's why I wanted like to talk to you too, so I can like go like step by step to you because this is like my thesis.
Okay,
So yeah,
I will add PV size and no need to worry. because we have to sum up the values and then it will be a fixed value. So it will not be a hard calculation for PV. Just scroll down.
Yeah. Here
So
also, yeah,
here I have 3 points for power loss minimization.
yeah, this one.
So
Uh,
normally, let me explain how we find out the power loss minimization.
mhm.
Normally in DG placement, we have a different possibility of placement for our DG. I mean, our DG can be our DG can be between bus number 2 to bus number 32. So the algorithm optimization will find out the best solution by using the power loss minimization. So here in this way, how I'm going to find the minimum power losses because our EV location is fixed.
Yeah, so okay, I'll tell you. The PV will be connected also here. It will be next to the station. Okay, so
Okay,
yeah, it will be next to the station. Okay, so it will not be like in any place. It will be next to the station. So for example, I like give the power here, for example, power to go to the station. Yeah, so um, also for this one, for the lowest power losses, I think we can ignore it right now. We can like keep the voltage and current. Mm,
I have one more question.
yes,
The question is about our load information.
your
So
yes. Mm.
I need details for how. Let me talk about queuing. So I need further details. As you mentioned here, we have 20 cars in station. So I need further details for our loads that are our cars here. So I want to know that how much will be how much numbers maximum we can take cards and how much will be their size.
Okay, so for example, I'm suggesting we have like maximum 20 car.
Okay,
And for example, let's say the size, we can, I think, fix like a specific size. For example, let's say 30 kilowatt hour.
okay,
Yeah, for each, like for each core.
okay,
It's like hypothetical system. It is not like a real system. Uh,
okay,
also, like for this, okay, for the customer satisfaction. Um, okay, so okay, just for the customer satisfaction, my professor like told me that the customer satisfaction maybe it will be like an equation. Okay, it will be something like, for example, alpha multiply, for example, the charging speed, for example. Okay, for example, plus beta multiply the price. Okay, price of a charging, something like this. It will be like an equation that I need to make based on, for example, literature review, based on like uh, it's like this.
okay. The equation is right here: alpha into charging
For
plus beta
example,
price of.
yeah, yeah, because the customer satisfaction is like a vague meaning, like it's like a very general term. So maybe the customer is satisfied if he charge fast. Maybe the customer is satisfied when he uh, come in the queue first. Maybe the customer is satisfied when the price of the charging is very little. It's like a broad meaning. This is what.
Okay, I just take the main idea.
Hmm.
So I need some further details for size of cars and the equation you write here, charging station and price of charging. So if you
Hmm.
queue these things, it will be easy for me to calculate it. I mean, I
Okay.
need, I'm looking for proper quotation for these parameters.
Yeah, yeah. It's because this is like my project, so it is like I need to specify it myself. So I'm not like tied to anything. I need to do this or this. It's my project, so I can
Okay.
uh, choose. For example, the prices I will try to find. I will check because I know some yeah, America, like United States, have like a booklet of prices. We can take it in consideration. Uh, I will also check this out, like the typical stations, how much it
Initially,
takes.
so yeah, exactly. Initially, initially we can take some simple or fixed value. So I'm going to design the program. So later we will change these parameters. So just make some calculation
Hmm.
and update. So I will start working on it, and later when we have done, then we will modify it further according to reference or research papers.
Yeah,
So
we can do it. Hmm.
first of all, modes of operation will be done. This is actually the load flow analysis. This will be done, and constraints will also be done. I need some calculation for queuing because the size of cars will be our actually load, and when we will without load, this program will not works. So just
Yeah.
mention these things and update.
Okay. Okay. So you want the queuing, right?
Yes,
Also, you need to know the size of the cars. Okay.
I will make a choice between 1 to 20 cars. How many cars you want to
I'm thinking
incorporate?
another thing. I'm thinking instead of like fixing it like this, okay, I can do like penetration. You know the penetration, 10% penetration, something like
10,
this. 10.
10% of penetration forward for our grid capacity.
Yes, exactly. So out of the whole power of this station, the
Okay.
the station will take like the cars will be how much. We can do it like this. I will just check it, double check this if it can
Uh,
work.
if you can take percentage of penetration, it also will be done.
Yeah, it I think it will be like this. But you can work on Python or just MATLAB?
MATLAB.
Only MATLAB, right?
Yes.
Okay, so also like do you provide like a step by step solution? For example, like I can like this be like this with you like on Zoom, for example, and like I watch you like do like the steps and I comment and do you provide something like this? Like because I think it will be hard for me to like have a video at the end that described everything because I will be asked, for example, why did I do it like this? What is the reason behind this? Why didn't do it? My supervisors,
Don't,
you know.
don't worry about that. When I will finish the program, I will explain step by step. I will mention where fast charging only and where fast charging plus V2G and where is our third mode of operation, where is our queuing and where is our maximum profit aggregator, where is optimization work, how optimization work, where is load flow analysis. I will explain each and everything. I already share a link with you. You can
Mm.
take a look at that. So no need to worry about that. So another thing, just scroll down.
Here, like this. Hello, hello.
Hello?
Hello, can you hear me?
No, I can't hear you. Can you hear me?
Yes,
Hello?
I can hear you. You can hear
So,
me?
yes, I can hear you.
Yeah.
Okay, queuing and the size of cards, 10 percentage of penetration, it will be fine. So, next, mention three step. I need price calculation.
Price calculation.
Because on based of price calculation, we will find out the benefit for our aggregator.
Yeah, this is actually one of the hardest stuff, since I think the for example, the aggregator will buy electricity, will take electricity from the grid and need like to sell it more and something like this, and take the electricity from the car and like resell it. So I will also check this one. It's
Okay,
fine. We can I can check it. Also, the system should work on 24 hours, right?
okay,
So it is just not 1 hour. It should work, for example, 24 hours.
sure.
Uh, Hello?
Hello, I can hear you.
Yes, yes. I hear you. So you can hear me now?
Yes, I can hear you.
Yeah, so I'm saying
Any,
the system should work 24 hours.
okay.
Okay, because I think yeah, 24 hours. I guess, yeah.
So I already explain. I already tell you about the explanation. No need to worry about the explanation. I will explain each part of MATLAB code when will done it. Okay.
Okay, and also the optimization, you will use Groovy or something like this, or which program do you use?
Initially, you mentioned that you are requesting PSO or GA. So in which you are interested?
Hmm. You can only do two, the GA and the PSO.
No, I can offer something more. IGWO, ABC. I will
Uh,
mention
do you use optimizer? Do you use optimizer like Groovy? I
Proby.
think it
Let,
will be faster, a lot faster.
let me check it about. Let me check about it, and I will update it. Update you.
Yeah, its name is like this, Groovy optimizer.
Spell
It's
uh,
like
spell spell it. GU
GUROBI.
GUROBI. Okay, I will check it and I will get back to you. So up to now, I think we have discussed. So give me time. Let me read paper again and check all the parameters. And later I will come back to you with the questions which I have in my mind, and then we will move further.
Yeah, if also you have like questions, I can, for example, talk to my supervisor to, for
Yeah,
example, like check also what do he mean or what he wants. We can do
yeah,
it like this.
yeah. There are many things we will discuss it before start of work. Okay.
Yeah, if you have any questions, we like you can send it to me. Also, like regarding those, okay. But if you have like any questions, like before you start, we I can like have a meeting with my supervisor and like make sure like everything is sorted out so no mistakes happen.
Okay, it will be fine.
Okay, perfect, perfect. This is good.
Okay, okay,
Yeah, yes. Also, just uh, 1 minute.
okay.
Just one. Okay. Yeah. 1 minute. Did you see my screen, right?
No, still
Yeah. Yeah. It
yes,
will come now.
I can see your screen now.
Yeah. So did you do this project before? It coordinated the charging of plug-in hybrid electric vehicle to minimize distribution system losses.
What do you mean
This.
before?
So I mean, like, did you work on such a project? This one. It is like I think it is like a straightforward paper coordinated the charging of plug-in electric vehicles to minimize distribution system losses.
You want to include this paper parameters into your work?
No, no, but I mean, did you work on it before? Something like this?
Yeah,
Did you?
I have done something similar, but I need to check this paper in further detail. So it will be better if you send me this paper. I will check it out and I will update.
Yeah, if because I'm trying to do this paper also, uh, I'm trying like to do it like as a practice. But and if you can like provide me with guidance, like it will also have like a different price than the different second one. I started this one, but uh, I don't know how to continue. So I will send it to you so you can check also if
Yes,
you.
I will take a look and I will update.
Okay, perfect, sir. Perfect. Okay. Your good name?